Well, dear students, in last video I told you about binding energy of nucleus and I derived an equation relating binding energy of nucleus with mass number, means number of nucleon and number of protons. Now, binding energy of different nuclei were calculated and it was found to vary from 2.23 MeV for 1s2 up to 1800 MeV for uranium-238. The binding energy of different nuclei were measured, I told you, from 1930 to 1950. This work was on. And it was found that binding energy of nuclei varies from 2.23 to 1800 MeV. Now, to understand the stability of a nucleus, we need binding energy per nucleon. Binding energy per nucleon. What is this binding per nucleon? It is the binding per nucleon defined as the binding energy of nucleus divided by its mass number A. Number of nucleon is represented by mass number A. So binding energy divided by mass number A is called binding energy per nucleon. Some people write it as BE bar is equal to BE upon A. And binding per nucleon determine the stability and also equal to the energy required to take a nucleon outside the nucleus. The energy required to break the nucleus by taking one nucleon. Higher the binding per nucleon, greater the stability. I hope you understand my point. Greater the binding per nucleon, higher the stability. And later on a graph was plotted between binding energy per nucleon and mass number. Once there was a question defined binding energy, what is binding energy per nucleon, यही पूछ लिया, यही बताया. तो total binding energy divided by mass number A is called binding energy per nucleon. So here, what is binding energy curve? Binding energy curve. It is a graph between binding energy curve. A graph between binding energy per nucleon and mass number A is called binding energy curve. This type of question we find there unanswered. So graph, the binding curve here, it is taken binding energy BE bar in MeV. And on x-axis it is mass number A. Plot shows the variation for 1s2, this is equal to deuteron, nucleus of deuterium is called deuteron. It is 1.1 MeV per nucleon. Then it jumps directly to 7 for helium, 2He4 के लिए 7 for helium, it is 7 for lithium, nearly 5.6. Then for carbon, it is nearly 7.6. For nitrogen, it is hardly 7.4. For oxygen, it is nearly 8. And then for iron, it is 8.8 MeV per nucleon. And then it decreases slowly and drops to 7.6 MeV. For uranium-230, it is important to remember this number, 7.6 MeV, million electron volt for uranium-238. Please remember this number. Now there are some conclusion from this graph and they are asked in the exam. I hope you may prepare your notes with the help of book or by listening my sound here, because it is not easy for me to write everything. The binary from nearly 50 to 80 has maximum binary. I have told you the confusion is there, binding energy. So people generally think कि energy which binds the nucleon together. No, it is equal to the energy released by the nucleon when they form a nucleus. Larger the energy released by the nucleons of a nucleus, greater is the stability of nucleus. I explained in the last video that to bring the particles very close, energy of the particle has to be lost. Like I told you, steam particles are converted into water. We have to cool that, and in cooling we are taking heat energy out. And further, when you want to solidify water, you again cool it, and in cooling we take energy out, and then more liquid becomes solid. In nucleus, the nucleon are very close to the distance between nucleon is of some certain Fermi order, 10 to the power 15 meter order. So to bring to such a distance, a large amount of energy to be released, and that is why there is a mass defect. So this binding energy per nucleon from 50 to 80 has maximum nearly average 8.5 MeV, and then it decreases sharply and becomes 7.6 for uranium-238. It means the most stable nuclei are from 50 to 80. Then as binding energy per nucleon decreases, it means they become unstable, and that is why the nuclei having mass number more than 209, they are radioactive. They keep on decaying into lighter nuclei. As a nucleus decays into lighter nuclei, mass number decreases, so binding energy increases. It means by emitting radioactive radiations, the nucleus become more stable. I have explained you while telling the model of nucleus. Okay, I have told you there that unlike atom, nucleus is not stable even in ground state, may not be stable. It becomes stable by decaying into lighter nuclei, which is the cause of radioactivity. I will discuss radioactivity in coming videos. So the heavier nuclei like uranium-238 has binary 7.8, it is most unstable. And if it decay into two lighter nuclei, then binary per nucleon increases, means they become tightly bound, and hence they have to release energy. But more the binding energy per nucleon here means more the energy released, and by releasing energy the nucleus becomes stable. So this is the cause of energy released during fission, and we are using nuclear energy as a source, clean source of energy in nuclear reactor. We are converting this energy released in the form of electrical energy, which we can use, and there are many other uses also. Iron 56 has binding energy nearly 8.8 per nucleon and most stable. Now if we come to lighter nuclei, again binding energy per nucleon decreases. Again binding per nucleon decreases. It means, and lesser the binding per nucleon, lesser the stability. It means the lighter nuclei are also unstable. Their stability will further increase if their mass number increases, and it is only possible when two lighter nuclei combine together and give a nucleus of higher mass number, then its binding energy will increase and become stable. This is case of fusion reaction. Hydrogen atom combine together to form helium or even carbon or nitrogen or oxygen. There are different reactions, different thoughts. In the sun, there is hydrogen and helium. Initially, the whole mass of sun was in the form of hydrogen. A large mass of hydrogen. You know how much mass is present in sun? You have heard about solar system. 99.9% mass of solar system is present in sun only. So that large mass of hydrogen was there. Due to large mass, there was strong attraction, and due to that strong attraction, a mass combined together, molecule came close, collide, and heat was produced, and due to that heat produced this fusion reaction could be possible there. Hydrogen nuclei combined to form helium nuclei produce energy. So I hope you have now, you have got it that lighter nuclei as well as heavier nuclei are unstable. Now there is very important topic here. From 30 to nearly 180, the average binding energy has a constant flat. Almost same सी रहती है यहाँ से ये आगे. It decreases very gradually, and this constant value of binding energy from 60 to 160 like that can be explained only, or this constant value binding per nucleon for these nuclei indicate that the force which hold together the nucleon inside nucleus, which is called nuclear force. Nuclear force. I'll take it just after this. Nuclear force क्या है? The force which is responsible to hold the nucleon together inside nucleus is called nuclear force. The constancy of the binding curve, but this is nearly constant. There is no sufficient variation. is the resultant, is the consequence of the fact that nuclear force is a short range force. शॉर्ट रेंज फोर्स. बच्चे सुनते हैं, टीचर बताते हैं बच्चों को बातें, लेकिन समझ नहीं आता शॉर्ट रेंज से क्या मतलब है. मीन्स इट मीन्स द न्यूक्लियर फोर्स applied by nucleon on other nucleon is short range. Means the nuclear force is effective on any nucleon by its immediate neighbors. Suppose I say that here is the nucleus and it has nucleon like this. So nucleon present here or here is subject to the force, nuclear force of this nucleon on any nucleon will be effective only on neighboring nucleon. The nuclear force is not effective between these nucleons. Larger distance पर जो nucleon होंगे, the force of a particular nucleon will not be effective. I will be discussing nuclear force. So due to short range force, mass number is increasing but binding energy is not increasing. Binding per nucleon is not increasing by large factor for this constant value binding energy. So it is a resultant of short range force, and the nuclear force act between immediate neighbors is also referred as saturation property of nuclear force. I will dictate it later on. So I hope you have got sufficient knowledge. Please read book for this, and then I will be telling some numericals based on binding energy in the coming video. But also read from the book, because something may be left. Teacher is not a perfect one. When we write, we consult so many books, and then more informations are written in the book. In lecture, some topic may be left. Although we try to cover the whole thing. So binding energy cover क्या है? It is the graph between binding per nucleon and mass number. By studying this, we try to understand the stability of the nucleus and try to understand why the energy released when two nuclei combine together or a nucleus breaks into two light nuclei. I hope you will enjoy it, and if you like my video, please first like the videos. They ask like and share the video, tell your friends, and please learn properly. By learning, you can rise your status, the status of your family, your town, your state, your country. Even though we are Indian, we should feel that we are Indian, but even then we are divided into states, and we will say that Haryana people are more athletic than other states. More athletes are produced in Haryana, whether it is the race or running or wrestling or different, there are some states from which there is no representation in these games like that. But when we get our Indian has won the gold, we feel very happy. So this is also opportunity for you to improve yourself by learning. Keep on learning. If you don't understand a thing in first reading, read it again and again. Still at this age, though I have sufficient knowledge of the syllabus of class 11 12, but when I make this video, I sit for half an hour or two, sometimes 2 hours, keep on thinking which points are difficult for student, how to explain, and no mistakes should be done, but mistakes occur. I have seen my video, I commit many mistakes. So you have sufficient knowledge, you can correct themselves. I have found mistakes even in a good book with me on a topic which is called degree of freedom and kind energy per particle of nucleus of a particle. Thank you. Please like the video, share, and ask your friend to subscribe my channel. It will encourage me to work here. Thank you.